Hey, good morning, everyone. Welcome here from Cornell University. I'm Ben Holton, the Ronald P. Lynch Dean of Cornell's College of Ag and Life Sciences. Thanks to our viewers and our panel of experts for joining us today. I want to give just a few upfront notes before we begin, some logistical considerations. So first, this event is being recorded and can be accessed at the same time, at the same URL afterward. So please, if you're watching this after we go through today live, click on the URL and you can see the whole live show. We welcome your questions in the chat. For the live audience, just click on the dialog box in the upper right corner of your video player, open the chat, send your questions. We'll be fielding them throughout the conversation today. And throughout our discussion, we'll be sharing links and resources in the chat as well. So watch for those. And if you're watching the archive recording, those links are available in the overview section just below the recording itself. So first, let me welcome our distinguished guests here, world-leading experts on methane, on climate, as well as the connection of science to policy. Unfortunately, Mary Nichols could not join us today, but we have two world leaders who are going to provide incredible insight on the science of methane and the opportunities to solve this challenge. So first, Ram Ramanathan, adjunct professor of global development at Cornell Cals. He's a world-renowned expert in atmospheric physics, dating back to early studies in the 70s. First,
Ben, I can't hear anyone. Can you all hear me? I sent chat message.
And the influence of climate change, how we can solve it by working with global environmental policy. In addition, we have right next to me, Bob Howarth, the David R. Atkinson Professor of Ecology and Environmental Biology at Cornell Cals, a leading researcher on methane emissions, a biogeochemist, understanding the sources and effects, consequences of methane on global warming. Also, Bob has been working really closely with state policy, including influencing the New York's Climate Leadership and Community Protection Act, and a member of the state's Climate Action Council to guide the law's implementation. So in today's keynote, we're going to focus on the science, how methane gets into the air, its impact on the atmosphere and global warming, and the most promising scientific and policy solutions that we should be mobilizing to get emissions down to zero. Now, the science is clear on methane. We know it's a potent greenhouse gas. It is a significant contributor to global warming. And as you can see in slide 1 here, we estimate, based on the scientific evidence, that 30 to 40% of warming since the Industrial Revolution can be attributed to methane emissions. So while methane may not last in the atmosphere as long as carbon dioxide, and we have to focus on all greenhouse gases, it is incredibly potent, and it has dire consequences because the heat that's trapped doesn't just leave the planet. It stays in our atmosphere, it circulates through our ocean, and it has cascading effects long after emissions are reduced. So the IPCC estimates that upwards around 50 to 65% of global methane emissions come from human activity, and that would be oil and gas, agriculture, food, farming, homes, and businesses, as well as waste. So no matter the source, the principal important point here is that it's dangerous to the atmosphere and we need to act accordingly. So if we follow the science, we know there's many opportunities to engage in creating positive solutions for methane mitigation. We have what's called a code red moment, a critical window to act aggressively to reduce emissions. And the beauty of methane is that when you reduce it, you can get real gains in temperature declines on a rapid timescale because, again, it's short-lived. So if you cut emissions, you can see warming go down. And we need to do this to bend the planetary warming curve and hold Earth's climate to no more than 1.5 degrees Celsius relative to the baseline pre-industrial. I also want to add, at Cornell, we're launching the 2030 project. That's a Cornell-wide climate initiative. The intention is to harness the expertise and innovation from across the entire university, regardless of discipline, and engage with stakeholders, partners throughout society to accelerate what we consider breakthrough science and climate solutions. This effort is focused on this decisive decade of action, and it's being housed in the Cornell Atkinson Center, which has connections to all of Cornell University, allowing us to make this effort incredibly impactful. Now, across the College of Ag and Life Sciences, we're working to support our farm, our food community. We're looking at net zero dairies. We're thinking about energy systems, looking at livestock feed management, soil carbon sequestration, and many other innovations that we'll hear about today in the conversation. And finally, in New York, the CLCPA provides a blueprint for where we need to go. We're committed to applying cutting-edge science to support various industries as well as citizens and communities with proven, effective methane mitigation strategies. This means working across agriculture, environment, policy, industry, as we seek out solutions that are effective, long-lasting, and of course, science-based. So with that introduction, let's dive into the panel. I want to open with a question for Ram on kind of the basic science of methane. Obviously, we think about greenhouse gases as a global problem. We're going to talk about the global perspective and then the New York perspective. But first, let me turn it over to Ram, and I want to ask just simply, why do we care so much about methane? Why is it so important, and why do we need to tackle this challenge? We may be having a technical difficulty. I don't know if Ram can hear me. Ram, can you hear me out there in California? Okay.
Ben, I can't hear anyone.
He can't hear anyone. So this happens sometimes. You're just going to have to give us a moment. We're going to try to get Ram on the mic. But in the meantime, I am going to shift over to Bob, who's right here in person. It makes it really easy. We don't have to worry about any clicking, any technological challenge, the good old-fashioned way of having a conversation. So I'm going to turn over to Bob. Bob, if you could talk a little bit about where methane comes from and what are the primary sources, why should we think about this in New York State? But if you could start with that level of conversation, would be really helpful.
Sure. Thanks, Ben. Methane comes from a lot of sources. Some of it's natural, as you noted in the IPCC report, but well over half of the total emissions now are human controlled, and they're multiple. It comes from fossil fuels, somewhat from coal, but more from the natural gas and oil industry. Natural gas is methane, and so it's really hard to develop and use it without emitting some of it to the atmosphere. It comes from cows, both from cow manure, but more importantly from the cow's gut itself. Bacteria in the gut produce methane, and they belch it out. It comes from rice agriculture as well, and from landfills, wastewater treatment plants, multiple sources. And it's an invisible gas. It's colorless, invisible, odorless. If we could look, there's a nice visual from the New York Times. I'm not sure if that's pulled up there or not, but we start with the picture showing a gas processing facility, and you don't see anything. That's the point. Methane's invisible. If we slide ahead just a little bit, we'll see if you take a special camera that's tuned to look at the infrared radiation absorption of methane. What looks like smoke there is not smoke at all. That's methane coming out of that stack. And you can't see it without the special equipment. So there are really 2 points I'd like to make. It's difficult to measure methane. You can't perceive it without special equipment. And also, when we talk about emissions, often people refer to the leaks. And in this case, what we're seeing is not a leak. That's part of the purposeful normal operation of that facility, is to release it, probably to control pressure for safety reasons. If we look globally, there's a fair amount of debate in the scientific literature still as to which sources are most important. In the 20th century, methane was rising quickly. For the first decade of this century, it was level. That was really good news. But over the last 10 plus years, it's accelerated and it's now going up at the fastest rate ever. Mm-hmm. We have a pretty good handle, I think, that this increase most recently is driven primarily by the oil and gas industry. Mm-hmm. But as to the relative magnitude of sources globally, animal agriculture might be the bigger source. We're actively debating that. It's challenging science.
Mm. Great. Well, thanks for explaining that. So it sounds like, based on this way of detecting the infrared, or it's like a seeing eye dog, that we can start to pick up on this. So whereas you can't smell it or see it or taste it, it's having this incredibly potent effect
Right.
on climate. And the sources vary. Could you talk a little bit about the New York State sources and how that might compare to the global average?
Yeah, absolutely. In New York, we have this climate law that you referred to, and it aggressively calls for reducing our greenhouse gas emissions statewide by 40% by 2030, just 7.5 years from now, and going towards carbon neutrality by 2050. The law also pays specific attention to methane. In the case of our use of natural gas in this state, a lot of the methane emissions occur out of state. They occur in Pennsylvania, West Virginia, Ohio, and yet they wouldn't be occurring except for the gas that we're using in this state. So our state law says those are our emissions. We take responsibility for them, because how else can you make a rational decision about how to reduce them? We're the only state in the country that does that. I think it's a great way forward. But using that novel accounting, natural gas makes up about half of the total methane emissions for the state. The largest source is heating our homes and our commercial buildings. It's cold here. We use a lot of natural gas for that, with a lot of methane emissions. Again, the methane emissions occur before the gas ever gets here, but it's associated with our heating. Electricity is big. And perhaps the surprise to a lot of people is that landfills, our solid waste systems, are actually the second biggest source, and quite large. When you put food waste and paper and things in a landfill, it decomposes, bacteria convert into methane over decades, and it leaks to the atmosphere. So that's a huge challenge we have in New York.
Interesting. Okay, yeah, that food waste angle, we can get into that more. Like, they've called the world's dumbest problem, right? Like, we have all this food that we produce, our farmers work so hard, it takes them months and years, and then the food gets wasted either in the refrigerator, or in some places it's on the farm itself. It ends up in a landfill, and so repurposing that into like soil health and other, to cut these emissions seems like an important.
Exactly, it's a real challenge. We also, for the waste that we've put in the landfills over the last 30 years, that methane is going to continue to come out over a period of time. So we have to trap it, and we have to use it wisely, but we need to solve the problem long term as well.
Great. Well, thanks for those insights. So I believe we have Ram now. Great. I see his hand waving, so that's great. It's wonderful to have Ram with us. So Ram, I'm wondering, Bob was talking a little bit about the sources, some of the work going on in New York State, where the sources are, thinking about beyond state borders. I'm wondering if you could we could take a step back, and given your career arc, where you started measuring these with balloons going into the air, and what is the science? Why does methane trap heat, and how do we know it traps heat? I wonder if you could talk a little bit about that.
Yeah. The first thing we do before we decide which is a greenhouse gas is to make measurements in the laboratory. It's very simple measurements. We have a tube of this methane gas. We shine infrared light and see on the other side how much of that infrared light is trapped. So it's basically quantum mechanics of methane, which makes it traps the infrared heat. So you can ask, where is the infrared heat coming from? Basically, the surface of the Earth emits it, the atmospheric gases emit infrared. And what methane does, it traps it. And the trapping effect is exactly like a blanket. On a cold winter night, you put a blanket over you, and that keeps your body warm. And that's exactly what methane does. So just like that blanket traps your body heat and prevents cold air outside cooling you, this methane traps that heat and keeps the planet's surface and the atmosphere warm.
So when we think about the fact that you can measure it in the lab first, and then you go out to the laboratory called the planet, and then you measure it again. And so at this point, I think it's unequivocal that we know methane is potent at trapping heat or infrared. And the sources, does it matter what the source is, or does the atmosphere not really care about that? And I wonder if you could talk a little bit about that connection.
Yeah. So let me ask that question in a slightly different way, Ben. How does the methane emitted, say, in California from our farms or from natural gas pipe leaks, how does it cause drought and heat waves in Australia, for example? And the reason is the atmospheric winds transport this methane within a year. gases emitted anywhere in the planet covers the entire planet like a blanket. So I have a video on this. To show that for a minute or so, Ben, so we see how fast
Great.
air moves methane around. Yes. So and the clock is ticking on the bottom. If you start looking at China, we have tracked using satellites aircraft in about 5 days. Air pollution from China can come all the way to Australia. So we don't want to blame just China for its emissions. Emissions from California, if you follow that pattern of winds, reaches the East Coast in about 2-3 days. And in another 2-3 days, air from the East Coast, from Ithaca, goes to Europe. So everyone, we are all in each other's backyard. And particularly if you look at South America from Brazil, the air transports anything over Brazil into Antarctic, again, a matter of 3 to 5 days. So what does all these 3 to 5 days add up? In about a year to two, methane emitted anywhere in the planet covers the entire planet like a blanket. Okay? So we are all interconnected. The lesson here is we're not going to solve this problem by blaming each other. We are all connected, we meaning everyone on the planet, and we have to work together.
Well, that's a great message because, recognizing the interconnectivity of people and the planet, and that's really what, when you boil down this challenge, what kind of world do we want to leave our kids? When we're already seeing, estimates from some studies here in Cornell, in CALS, and part of the Dyson School have shown that a fifth of crops are already failing. Yields are reduced by about 20% because of climate impacts that are happening today. And if we don't do something about this, it's going to be incredibly challenging to continue to meet the food demands of a world population, the environmental considerations, biodiversity. And so it is really an all hands on deck urgent moment. And methane is one of the principal components that we really need to find ways to cut emissions and bring them down to zero. So I really appreciate those thoughts, Ram, especially the connection and how quickly it becomes a global blanket as opposed to something that stays local. And so with that in mind, I want to go back to an earlier point that you were making, Bob, about New York State and the emissions, and recognizing that it sounds like your evidence and others pointing to fossil fuel emissions that are happening, and that is the biggest source in New York State. We talked about waste. Agriculture from dairies, which we'll get into, sounds like a smaller component of total emissions here in New York, although really important to focus on all of the sources.
Right.
Now, I'm just wondering if you could talk a little bit more about, the way that the CLCPA is thinking about this problem a little bit differently, in that we need to consider, like, the boundary conditions need to change, to Ram's point. I wonder if you could talk a little bit about that.
Sure. I mean, the CLCPA, as I say, has taken this novel approach for how we take responsibility for our emissions. And it's particularly for the fossil fuel emissions. New York banned high-volume hydraulic fracturing for shale gas, right? And yet, in the time since we've banned it, the use of gas in the state has increased dramatically. It's increased faster than in any other state. And there are significant methane emissions associated with the process of high-volume hydraulic fracturing and using gas and getting it to market. So, we need to recognize that those emissions are happening because we are consuming the gas that's heating this building at this very moment, right? So I think that's a real breakthrough. If the way New York used to look at our greenhouse gas accounting, methane showed up as a tiny, tiny blip. It was all carbon dioxide. With the new accounting, methane makes up more than a third of the total greenhouse gas emissions of the state.
Wow.
And so the CLCPA says we need to reduce those emissions by 40%. I think that's the most critical targets by 2030. That's 7.5 years from now. how do we do that? The law is silent as to how to do it, but it set up this group called the Climate Action Council. I'm one of the members. There are 22 people on it, a lot of important people in state government, the Commissioner of Environmental Conservation, Commissioner of Agriculture and Markets, Commissioner of Labor, et cetera, President of NYSERDA, and then some of us are appointed on the outside. The law specifies that the council develop the blueprint for meeting the goals of the law. And it challenged us to come up with a draft implementation plan by a few months ago, back in December, and we have to have a final plan by the end of this year.
Wow.
So we have a draft plan that's out there. We are welcoming public input on it because it's a good plan, but we can make it better. But let me give you an example of the sorts of things that the plan calls for. One is to no longer allow fossil fuels to be used in heating or other energy use in new home construction 2 years from now, soon. And that helps, but we also still have 6 million single-family homes in New York which are heated with fossil fuels currently. 4.5 million of those are heating with natural gas. We need to transform those houses too. It's a significant challenge. But we have a concrete plan for by 2030 backing 1.5 to 2 million of those homes out and retrofitting them in a way which is going to work for the consumers. It's good for the state economy overall. It's going to be okay for consumers. And in doing so, through those plans and moving more towards renewable electricity, the plan says that we will cut our use of natural gas statewide and methane emissions from that by 33% by 2030 and by half within the next 15 years. So I really think that is powerful. And if New York can do it, we can set an example for other states, the rest of the world. I should add that often people say, well, we need to use natural gas. We just need to fix these emissions and reduce them. It's incredibly challenging. The level of emissions we're talking about are 3 or 4% of the gas that's produced. It's a small number. It's just that methane is such a powerful greenhouse gas that adds up. And of those 3 to 4%, some of it's leaks, old pipes and things like that. New York City has really old pipes. How many hundreds of billions of dollars do you want to spend to replace the pipes of New York City when we need to get off of natural gas over the next 15 to 20 years anyway?
Amazing. So
our plan doesn't worry so much about the leaks. It's moving towards a solution.
Great.
And again, some of the emissions from the oil and gas industry are just a purposeful part of the operation. So an example is we move gas to market in high-pressure pipelines. If you want to do maintenance on those pipelines, you can't just go out and weld a pipe full of methane. It's a hazard, tremendous hazard, right? So you got to take the gas, the methane out of the pipe. And industry practice is to blow it off to the atmosphere. That, it doesn't happen every day, but every time you do maintenance, it's a significant emission. Are there alternatives? Well, not really that the industry's worked out. That is the approach. And you think about it, how else would you take a high-pressure gas and remove it somewhere safely? It isn't an easy fix. So the trick, I think, for the fossil side is to just move away from fossil fuels.
Great. Thanks. Well, to your point, New York is already taking leadership here, maybe building off what California did and being maybe even more aggressive in some of the approaches that are taken. And it also sounds, one thing about methane that's really interesting as we turn back to Ram is it's kind of like the ghost pepper sauce of a greenhouse gas, because a little tiny bit goes a long way. And even though these 3% of leaks that you're talking about or emissions don't sound like a lot, they add up over time. And they trap a lot of heat because they're so potent. So it is something we all have to keep our eyes fixed on and find solutions and be aggressive and do it in a way that brings about solutions and co-benefits for society. And so, Ram, I want to go back to your earlier point where you're talking about this incredibly local to global connected system. And one of the things we're trying to do with the 2030 project is say, let's go local to global and back again, because that's really what's going to be required. I wonder if you could talk a little bit about where the United States is starting to angle, most recently some agreements with China on methane, and maybe you could talk through that connection, because obviously even if one state takes action, it's not going to. We're totally aware of this. That doesn't mean we're going to solve climate change. So we do have to coordinate. So maybe you could talk a little bit about that, Ram.
Yeah, Ben, just one comment I want to make. You said ghost pepper sauce. I think of methane as the Indian spices with spices. Just a tiny bit enough. I want to comment on, just to answer your question, Ben, why what Bob is doing in New York and what Cornell is championing this 2030 is so critical to save billions of people suffering from climate change. So let's take Bob's example, cutting down methane emissions by 40% by 2030. If New York not only does that, but promotes that to the rest of the US and from there to the rest of the world, if the whole world accomplishes this 40% reduction by 2030, we can cut the rate of global warming by half within the next 20 years. And that's one of in fact, the only solution I know of from avoiding overheating of the planet. The planet is set to cross this dangerous threshold warming of 1.5 degrees in about 7 to 13 years, around 2030. So that is why I'm super, super excited about what Cornell and New York State are trying to do to cut methane emissions. So let's not forget that it's a pivotal step.
Yeah.
So if we do this, cut the rate of warming by half with methane, what are the other benefits? We shouldn't forget that. We avoid premature deaths of about 250,000 every year. So in 20 years, we would have saved about close to 5 million lives, which would have been lost, premature deaths. And we will be saving about 26 million tons of crop loss every year, mind you, because of the ozone, which is produced by methane. Ozone is deadly for crops, and it also causes asthma. That's why the deaths save. So this is something which goes not only climate change, of a lot of the environmental issues we are facing.
That's great. So yeah, it's oftentimes, I think to your point, we're focused on the warming effects, which are incredibly important, but the co-benefits for human health, for environment, for food production, especially through things like ozone, are really important to keep our mind focused on, because we'll see tangible benefits when emissions come down, even locally. You can cut methane and you can start to see local benefits for human community health. So while it takes a little longer for the planet to cool down as we cut emissions, you get these great co-benefits. And I think that's such an important point for everyone to understand. And I think that's why a lot of us are leading with what we call informed optimism, because we know the solutions can work. We know we can cut emissions. The science is clear on that. So we can be optimistic, but we have to be informed about the real problem that we're confronted with. And so that's the balance point I think we find ourselves in science sometimes, like how do we balance that out? And with that in mind, before we go to an audience question, I want to go back to Bob real quick. So picking up on this angle of sort of co-benefits, here in New York State, we're the 4th largest dairy producer, incredibly important to our economy. And there's a lot of talk now about net zero dairies, and Cornell Cals is doing work on that. I know you're thinking about it. I wonder if you could just talk through what does that mean, like a net zero dairy, and what are some of the intervention points to try to make that happen?
Sure. The number one greenhouse gas source from our dairies is methane. So it's not the largest source of methane in the state, but it's the biggest issue in terms of the greenhouse gas consequences from our dairies. And it's twofold. When we store and use manure, methane is released from that. But far more importantly, it's coming from the cow's gut. And there's some very encouraging research suggesting that if you change small details in how the cows are fed, that it could make a big difference in how much methane is emitted. And I think there's a lot of exciting work that's starting now in Cal's on that. I'm on the periphery of it, but I'm excited to watch it happen. And I sense a lot of interest from the New York farmers as well. You know, I've talked to several farmers, I'm sure you have. They're excited about trying this out. So if we can get the science right there, I think it could make a real difference. On the manure side, you and I were talking a little bit before we started the show here. It's a relatively small part of the methane. Doesn't mean we shouldn't deal with it. But more importantly, how we handle manure causes severe problems for air quality from ammonia emissions and from water quality. Lakes are probably contributing to harmful algal blooms in our lakes here in the Finger Lakes, for instance. So we need to do a better job with manure, and we should tie that to how we try to reduce the methane from it. But I would view it as a whole. And again, I think there are a lot of positive alternatives we should be exploring there. And I find, again, the farm community responsive. I think they want to try and do a good job on that.
Great.
One other issue on the coal benefits. As part of our Climate Action Council plan, there's a cost-benefit analysis. How much will it cost to transition our state to carbon neutrality? And it's a big number, quite frankly. But it's also benefits of particularly health, but also climate. And the cost of doing nothing to our state is larger than acting. The state as a whole will save money by reaching these targets. And a lot of that is in terms of the human health aspects: asthma, premature deaths, missed school days.
Wow.
And one other detail I should add is that when you burn natural gas in your home in a cook stove, the methane's largely consumed there. That's okay, but it's producing a lot of other pollutants in your home, and it turns out that's a severe cause of indoor air pollution. Getting natural gas burners out of our homes will be a huge benefit to the public health of our state.
Great. Wow, great point. And you know, talking about the science leading the way, and recognizing the science as a process, and yet the evidence is really clear on the effect of methane, and that there are co-benefits that you know farmers can get. I personally believe, like, hey, let's make sure carbon's a commodity that farmers get paid for when they're doing things that are not only benefiting their operation, but really benefiting society as a whole. And there's a lot of exciting work happening there too. And in our net zero dairy work with Professor Joe McFadden, these new chambers where we're going to be able to, respiration chambers, you can measure if you change the feed that's going to a cow, do emissions go down? How much they go down? Very scientific, and a lot of innovation coming out of there. So it's really, really great stuff that's starting to happen. We need a lot more, but we're seeing evidence of good things starting to happen.
Yeah, no, it's exciting, and you know, in addition to those growth chambers and being able to measure methane real time as a function of the diet, as you know, we're trying to mount more of a campaign to better measure what the emissions from farms are in the field. And because that's more uncertain than a lot of people think. I've given you some numbers. We know them as well here as anywhere, but they're uncertain. It's difficult. And so we want better numbers there, and we'd like to be able to verify that what we can demonstrate as an improvement in the lab will work on a real dairy farm. That's important, right?
That's great. And for those out there, you hear the word uncertainty. The way I like to think about uncertainty from a scientific perspective, and that's the playground of science. That's not, you know, we hear uncertainty and we get freaked out like, no, that's where we are refining our understanding, and that's how we drive new questions and new measurements, and it's a different kind of uncertainty than sometimes is heard outside of scientific circles. So it's really great stuff. Now, what I'd like to do is turn to some audience questions and bring them into the conversation here a little bit. So we have a couple of questions coming down the way here. We have one from Ellen Lockwood. MD 6569, go Big Red. I'm wondering, so the question here is, can you please comment on the practice of burning landfill methane to produce electricity and CO2? So let me start with you, Bob, on that, and then we'll see if Ron wants to jump in on it.
Sure. I mean, again, there's a substantial amount of methane coming out of landfills here in New York, but globally, and that's a legacy to poor practices with our waste in the past. Those methane emissions are going to continue. Eventually, the bacteria will eat through all of the decomposable stuff, and will solve as long as we move forward with better disposal. Meanwhile, but what do we do with the methane that's coming up? And the worst thing is simply to let it go to the atmosphere as methane. Better is to capture it and burn it. Better yet is to capture it and burn it towards some purpose. And best is to capture it and use it for some purpose without burning it. So what we are pushing for in the Climate Action Council is to capture it and feed it to a fuel cell to produce electricity, as opposed to burning it. When you're burning it, you're going to get carbon dioxide either way, but the other pollution loads are far less. And often these landfills are an environmental justice issue. They end up where they are for a reason, right? It's not accident.
Absolutely.
And so if you take the methane that's coming there and you burn it and produce a lot of local air pollution, that's a hazard that we need to be aware of. Fuel cells are more expensive than simply burning it for a generator, but I think a majority of the people in the council believe that's something that we should subsidize out of environmental justice.
Yeah, great. Yeah, that environmental justice point is so critical in this whole conversation about climate. We can't leave anyone behind, right? And historically, groups have been left behind, and environmental challenges, bad water, toxic air. And so now is the time to make sure that those benefits are there for everybody. And so it's a critical point. Thanks for mentioning that. So Ram, I want to turn to you. Maybe you could touch on this question. Also, if you could expand into where you see other solutions playing a key role in methane and getting methane down.
Thanks, Ben. The landfill is about 1/5 of the total methane emissions. So it's a huge part. And so what is in that landfill? It's basically processed food we throw into the garbage cans, which are carried to landfills, and other organic waste. San Diego, for example, I've been pushing this for the last 10 years, is to ban throwing food into the garbage cans. So where would you put it? There are what's called biodigesters. You throw your food into the biodigesters, at least uneatable food, and that converts into part fertilizers and part methane. I mean, UC Davis, your pharma institution, had a huge demonstration plan. So it's doable, it can be done, but it requires state policy to not to throw food. The other one is that it turns out about half the food is, could be consumed by us. So that food is about half the food is taken and given to those, who are below poverty line, etc. So there's huge side benefits in focusing on the food waste and then the organic waste we throw into our garbage cans, which goes into the landfill, and some of it gets into methane emission. But what we throw into the landfill, that methane, I think Bob talked about it, can be captured as renewable fuel, and then you burn that in in your furnace, and then that gets converted to carbon dioxide, which is about 20 to 100 times less potent than methane.
Good point. Well, okay, thanks for mentioning that, Ram. So, a lot of this, the challenge with methane is about repurposing it. Getting emissions to zero as quickly as possible. And in some cases, it's so interesting how connected it is to our food system, the choices that individual consumers are making, our energy. Like methane is connected to all of these things, and so we have to take a very holistic perspective, because it's just like squeezing a balloon. You don't want to squeeze that balloon and it just goes out somewhere else, and that's why we need these really comprehensive solutions that we've been talking about here today. So it's really great to get into that conversation. I want to turn to another question here. So this one is more about tipping points, and so I'm going to turn this one to Ram. What I'm going to frame as tipping points, but of course you can frame it however you want. But are there concerns? This is from Sam Levis. Apologies if I didn't pronounce the name correctly. Are there concerns about increasing methane emissions from the thawing of permafrost as the planet warms? I wonder if you could talk a little bit about that kind of tipping point in the climate system.
I mean, it's an extremely critical question of the day. And let's start out by saying methane emissions are increasing at alarming rates over the last 7 to 8 years. Scientists don't understand why. There are many potential causes, including emissions going up, but the other is as we are heating up the land, there's more coming from wetlands. Remember, wetlands is the largest natural source of methane. The second issue is permafrost and the polar oceans. They are all heating up at 2 to 3 times the global rate. So far, The limited measure seems to suggest that is not the primary source of why methane is increasing. Okay, so we need to understand that urgently. But in the future, if we don't arrest the warming at somewhere between 1.5 to 2, I think 1.5 is a lost cause. We won't be able to stop the warming from crossing that because it's going to happen in 7 to 8 years. But certainly, if we can keep it below 2, we can keep all these issues under control. Beyond 2, it's anybody's guess. Is the tipping point going to come because methane is going to increase uncontrollably, or glaciers melting rapidly, or the dieback of Amazon forest? There are many such tipping points we are all concerned about, and we don't have clear idea how these tipping points work and at what temperature they're going to be tripped.
Yeah, and so to your point, that's kind of uncertain, and yet we know it's lurking.
Yep.
You know, it's not a boogeyman. This is something that could really happen. We're seeing evidence that permafrost is thawing. We're seeing evidence of the Yedema soil, which is this massive amount of soil material that was buried during all the wind and dust that was blown around as we came from the Pleistocene to the Holocene, stored all this organic matter and buried woolly mammoths alive. That is thawing out. And as that thaws, it can end up in melt ponds. It could release CO2 directly, or it could release methane. So you know, this 1.5 degree threshold that has been discussed, I think Ram has pointed out for quite a while now, it's likely we're going to hit that sooner than later. And so we need significant global action on this problem. So go ahead, Bob.
Just one more answer.
Sure.
I agree completely with what Ram and what you said. It's a huge concern. The precautionary principle would tell us, let's not do the experiment to find out how big of a concern it is.
Yeah.
I think the evidence to date is that it's not driving the increase we're seeing to date. That's the good news.
Yep.
But in addition to the permafrost and the organic matter and the bacteria that produce methane, we have what we call a methane clathrate, which is a frozen form of methane in water that forms under pressure and relatively cold temperatures. So that underlies the permafrost in lots of places. It's also on the continental shelves of the oceans in lots of places. And if that were to be warmed, there's a tremendous amount of methane in that. And so, again, some of it's melting. There's no evidence that it's accelerating its melting yet. And the evidence is that when it's melting, it's not reaching the atmosphere yet.
Yeah.
But another concern, another reason to keep the planet below 1.5 degrees.
Great. Thanks for pointing that out, Bob. And I do want to pick up on one thing that Ram was talking about. So we know methane emissions have been rising globally and at an accelerating rate. And there are questions that you pointed out earlier about, like, what is the principal cause of the rise we're seeing? And I know you worked with isotopes. So if we could take a moment here for all those science nerds out there, and we'll just say, what are these isotopes? What have you been finding with isotopic ratios in terms of what the sources may be behind this rise?
Yeah, no, I'd be delighted to talk to that. There are two things to think about. The methane level was level in the atmosphere. It wasn't going down. Emissions were steady, but it wasn't increasing at the rapid rate until about 2005, 6, 7. And what happened globally in 2005, 6, or 7? And the thing which strikes me is the development of shale gas in the United States and Canada from high-volume hydraulic fracturing. It wasn't commercially developed before then. Since then, virtually 90% of the increase in natural gas production globally since then has been in the United States and Western Canada from shale gas. It's now 80% of our natural gas production in this country, and there are every reason in the world to believe it has fairly high methane emissions. Tony Angraffia and Renee Santoro and I published a paper cautioning people on that way back in 2011. Data availability was poor at the time, but we said, pay attention to this. Methane emissions from the shale gas could be a big problem. Ours was the first paper on it. They're now, our paper's been cited more than 1,700 times since, and there are hundreds of other studies, and we're kind of right. There's a lot of methane coming out of shale gas. If you take the amount of shale gas that we know has been produced, because we know precisely when that started, and take the best data you have on how much methane is emitted from it, it accounts for at least half of the global increase in methane since then.
Wow.
The other evidence we have is the stable isotopic composition. And the most methane is carbon-12 at its core. It's a single carbon atom with 4 hydrogens around it. It's a stable carbon-12. Some of methane has a slightly heavier carbon middle, carbon-13. And when we look over the beginning of the 20th century, globally, there was no change in that composition. But starting in 2005, 6, 7, the methane started to become lighter, a little bit less of that carbon-13 in it over time. And there are several contributors to that. One's probably a change in the amount of biomass burning over time. But I published a paper in 2019 pointing out that the methane from shale gas has a little bit less carbon-13 in it than does conventional natural gas.
Wow.
And so the amount of increase in shale gas is sufficient to explain that. And again, would suggest that half to 75% of the methane increase globally over the last decade has come from shale gas, primarily in the United States, which I think is, and not everyone agrees. The science around this is complicated. I think we'll have a much better handle on it as the satellite observation data becomes better. And one other isotope which I find very exciting is the carbon-14 in methane, radiocarbon. And we know as of the end of the 20th century that about 30% of all of the methane in the atmosphere is coming from ancient sources from that value. We don't have good data globally on it since. I think there should be a priority to go out and do that. But there's been some really exciting work by Vaz Petrenko and colleagues at the University of Rochester, nearby colleagues, and they've looked at the amount of carbon-14 in methane that's been laid down in glacial ice over time. And what they've been able to demonstrate is that prior to the Industrial Revolution, there was no ancient methane in the atmosphere. It's all recent biological stuff, which tells us that 30% that we had as of 2000 is all from fossil fuels. It's not a natural seep source, which is kind of a game changer. So I think more research there combined with more satellite data within 5 to 10 years, I think we'll have a much, much better understanding.
Great. Wow, it's always interesting to hear the story of the science and like these isotopic fingerprints. Like these sources have a fingerprint, and then if you measure that, you can figure out who was the culprit, who's behind the crime. And all these techniques and technologies are going to come together to refine that science. And none of them are perfect.
So using multiple ones, when they agree, then we're confident.
Yeah, so this idea of sort of a convergence of data, and then we draw our best conclusion at that time.
And one other piece of convergence there is that we can measure methane by satellite because it's such a powerful infrared absorber. The satellites are getting better and better, but the satellite data to date, again, suggests that over the last decade, between 30 to 60% of the increase in methane globally was coming from the United States.
Wow.
Also consistent with the shale gas source.
Great. Well, thanks for explaining that to our audience. And so now we have about 10 minutes left, roughly, maybe a little less. I'm going to turn to Ram. I've gotten to know Ram over the years, and one of the most exciting things that I've learned from Ram is the power of education in all of these challenges. And I'm wondering, Ram, if you could talk a little bit about how you see education as this incredibly important solution to every greenhouse gas, and what kind of work you've been doing to bend the curve, as we can see behind you.
Thank you, Ben. So if you ask the question, why are we not taking the sort of rapid actions on climate change which we need to take? Just let's start from the US. We have tens, if not hundreds of solutions. So we are not taking action, not because we lack solutions. I see it as we lack public support. So we need massive societal transformation. And that societal transformation, I feel, can and should take with education. Not only educating every college student on climate and environmental issues, and it was behind that goal we started the Bending the Curve education program in California. And Ben was involved in this, and we developed a course which all undergraduates, including majors in social sciences, arts, and anyone can take this. And now it's being taught in almost all the campus of UC. It's taught in Stockholm University and some of the East Coast campuses. So I hope every university would take up this challenge of educating all its students, undergraduates, graduate students, on climate change, the urgency of it. But we can't stop there. We have to go beyond. We have to educate the private sector because they have to be part of the solution. And the general public. So let me take a minute to address the general public issue. So as we all know, you don't have to be a political scientist to know this. America is divided no matter what the issue is. Unfortunately, climate change has become a political issue and got put into a number of cultural justice issues and political issues. Climate change got mixed up with that. So we have to unpack climate change from all the issues that divide us Americans. Climate change is not a political issue. It's an issue of human suffering. It goes beyond and across party lines. So that education has to be developed. Experts in communication and even advertising agencies who know how to communicate. We need to team up and develop such a program. The question is, how do you deliver it? It has to be targeted at the local community level. So I'm thinking of the delivery mechanism is mainly faith-based through churches, through synagogues, through mosques, through temples. And the NGOs can play a role. But I think universities have to have a strong participation, if not leadership in the issue, develop the communication that unpacks climate change from all the issues that separate us, but make sure that climate information is scientifically robust and not mixed up and corrupted with political issues.
Wow,
Thank you, Ben.
Great point, Ram. And, I think the inspiration of climate change can divide us. Or, and this is our choice, it can unite us, right? Yes. Through education, through solutions, through co-benefits, through transformation of society, and to think of the world as an interconnected world. And as has been discussed today, what happens locally affects the global commons here. And so we really need to think about as many solutions. And I like to say, and others have said before, we need silver buckshot. Mm-hmm. There's no silver bullets. And not every solution is going to work. So in some ways, we need to be willing to fail fast and learn quicker and make sure that science is there at every step to guide which solutions are working. And when they're not working, let's make them work better. And if they're not going to work, we have to be really clear on those points as well. So this has been a great conversation. I think we're starting to run near the end of time here. We have about 5 minutes remaining. So I'm going to now just open to both Bob and Ram. We'll start with Bob. Just last thoughts that you want to make sure the audience understands about methane or anything in particular related to climate that you would like to leave this audience with.
I think I'd like to follow up on what Rama just said. He described climate change in terms of human suffering as an issue. And you, in your introduction, pointed out the work at CALS that we're already suffering a 20% global food loss because of climate change. I think too often climate change is just seen as another environmental issue. Polar bears. And, we all love polar bears. Yeah. But this is it's a true human suffering issue. The environmental justice issues are there first and foremost. And I think we need to be pushing that. This year is going to be a real challenge. If you look what's going on in India with the heat waves and how that has hit the wheat harvest for this year on top of the war in Ukraine, which is not climate change, but the other is. People are going to start realizing we have food shortages, and climate is a major driver of that. So we need to, that and water shortages and the direct heat effects of health are all things we need to make people cognizant of, and message as part of that educational aspect.
Great. Thanks for pointing that out. And I really believe agriculture is one of the most important industries of the 21st century, if not the most important. I'm a little biased. I am the dean of CALS, but I think if you look at our food system and the way it connects to human health, if you look at the way climate is disrupting food, and you think about the capacity to slash emissions and maybe even get to net negative emissions, a lot of that can happen, but a long ways to go. And so it's important that we take action now. And human suffering, as you pointed out, that's what all of us scientists are really most concerned about, is that humans are going to suffer. We are already seeing suffering.
We are suffering.
Yeah, and that's why we're trying to push hard on the solutions. So Ram, the floor is yours to end the conversation here.
Oh, thank you, Ben, for that pressure. Let me just conclude 3 thoughts I would like the public and the audience here to remember. First, we are all interconnected as far as climate change is concerned. So what do I mean by that? Emission anywhere is global warming everywhere. It's exactly like COVID, where infection anywhere leads to a pandemic globally. Okay. The second to remember is that while there's lots of doom and gloom, climate problem is a solvable problem. We have most of the solutions we need, so there is still time. So don't lose your hope. It just requires massive public support and public-private partnership. The last point I want to add with respect to methane is we are now in a climate crisis mode. We have already seen fires, droughts, floods. And the recent UN report says America is one of 6 countries which is suffering the most from climate change. And methane mitigation, because it is so potent and because it's short-lived, it stays in the atmosphere only 10 to 12 years, and because we have solutions. Bob outlined to us many of the solutions. So that's one way to get ourselves out of at least half the crisis mode. The other half has to be make the planet fossil-free. Okay? So those are the 3 thoughts I would like the audience to keep, Ben.
Great. Well, great final thoughts here. I just want to thank everyone for your contributions today and your questions. And please talk about this issue. Don't let this stay within this conversation space. The key is that you talk about it. Talk about it with those who might disagree with you, and do it in an agreeable way. And I think this is a critical challenge of our time. And it can also be a hopeful future if we continue to focus on some of the solutions we heard about today. So thank you so much for joining us. Take care. Have a good day.